Hi, in this video, we're going to talk about the Python's hash function and the Thunder hash method. So we've already seen that we can hash the Python's built-in types such as int. You've seen this before. For int, it's just it returns the integer itself until it reaches some pretty big value, then it starts wrapping around. Okay, and we can also hash strings. So for example, we are going to hash the strings here and there. It's a single string. It's going to hash into some kind of odd, weird looking number. Now, if you kind of remember these numbers, and I'm going to run it again, and I'm going to run it again and again, and you can see that these numbers actually changes. So what actually happens is each time a new Python process is started, it actually has a different random seed for string hash generations. So that's why across different Python processes, even for the same string, the hash is different. Now, in the same process, though, the hash for the same string is going to be the same. That's why I run it twice. In the same process, it's the same. And the reason for that is, it's a security feature. It was not like this before Python 3.3. Before that, the string hash were stable, meaning it's the same across different processes. But since 3.3, it's changed. There's more details that I found here. It's kind of an interesting read if you want more information. Now, this can be a problem if you store the hash in some persistent storage, right? So on a disk, you come back, a day later, a year later, and you try to, use that hash to find your data. You couldn't do it because now it's a different Python process. So if you want a stable hash, maybe you can use the hash lib, which contains the cryptographic hash functions, or we can write our own, just like we've done it previously, right? And also we can hash multiple values if we put them in a tuple. So it's important that we say hash parentheses and then a tuple of multiple values. So an example here is, well, I already typed it out, and that's that. It just gives you a number, and obviously because this has a string as part of the tuple, run it again, it's going to look different. Now, hash is a built-in function. Just like many other built-in functions, it's actually just a syntactic sugar for object that dot dunder hash. So any user-defined type can define dunder hash if we want to have good control over how our user-defined type is hashed. Now, dunder hash is actually defined by default. It's there, but just like the dunder equal is also defined for user-defined types by default. It may or may not do what you want it to do. And another kind of an odd thing here, it's actually not odd when you think about it, but I just want to point it out, is if you implement dunder equal, then the default dunder hash actually kind of disappears. So if once you define dunder equal and you still want your object to be hashable, then you have to explicitly define dunder hash. And the reason for that, I think, it's because once you define your own dunder equal, you're probably comparing a set or a subset of all the attributes. And then Python really wants you to define, dunder hash yourself to hash the same set of attributes. So let's see how it actually works in an actual example. So remember, we've been talking about students, we've been talking about CWIDs and names. So if to see if two students are the same, then we should check if their CWID is the same and if their name are the same, right? So when we do the hash, what we want to do is then we hash both the CWID and the name as a tuple. Now, something that may not be obvious in the first place, but it makes a whole lot of sense when you think about it, is that if two objects are the same, meaning their Dundee equal is true, then if we hash those two objects, the hash should be exactly the same, right? Otherwise, I mean, if these two same objects have different hash, then they might end up in different buckets, which is going to be very weird. Now, conversely, if the Dunder hash for two different objects use the same hash, it does not necessarily mean that those two objects are the same, though, right? Because again, if we think back to our hash functions and all that, the fact that two different objects having the same hash just means there's a collision, and hash functions are allowed to produce collisions, but those two objects may not be the same object, right? Okay, now that we have a user-defined type that defines the hash method, let's see how it can actually be used. So here I'm just going to import the hash table that we implemented, and I'm going to allocate a student's hash table, hash QP table, and I'm going to create two students. I'm going to insert them into the hash table. Now I will want to see if this first student, 1, 2, 3, 4, 5, 6, 7, 8. John, is it in the students? Well, it should be, right? And then I'm going to try another student that has the same name, however, is a different CWID. Now, this student should not be in the hash table. So let me run that, and there we go. The first student is in the hash table, second student is not. So in order to understand a little better how the hash of some particular attributes affect the operation of a hash table, let's do a little bit of thought exercise here, or you can actually try out the code here. So what I'm doing here is I actually create a student and I insert that student into the hash table. Now, after I insert it into the hash table, I actually change that student's name to a different name. Okay, and then I'm going to try to see if that student within the new name now, is it in the hash table. Now remember, because this S1 is the object that is inserted into the hash table, so what's in the hash table is the student with the new name, right? So the question is, can we find it? So think about that for a moment. And I'm not sure what your answer is, but you might expect us to be able to find it because that this student with the new name is in fact in the hash table. Now, when we want to run this code, the answer though is that it cannot find it. It cannot find the student with the new name, even though the student with the new name is in the table. And the reason for that is that because the student, when it was inserted into the hash table, it was using the old name. So that old name gives a hash. However, with the new name, that is a different hash. And so in the contains operation, it would use the hash, the new hash, to try to locate the student, but it couldn't find it in the right bucket because obviously it was in a bucket that's That's a result of the old and different hash. So the moral of the lesson is that once a object is hashed into a hash table or is stored into a hash table, its hash should not change. So in that regard, it should be considered an immutable object. Otherwise, as we just saw, it cannot be found again. So that is something in an immutable object might be something that you would read about when you say look at the documentation on set or dictionary. So yeah, the keys in the dictionary must be immutable, and the objects that you put in a hash, put in a set must be immutable and obviously hashable. And here's a little article that I found kind of useful for me when I want to understand the Dunder hash better.